All right, hello, all you wonderful people. Let's move over to the lesson. So absolute value equations, we're going to bring together what we covered yesterday and some of what we did last week. So we covered absolute value equations last week. Now we're gonna be using absolute value inequalities. So that actually should say inequalities. So graph the solutions and write in interval notation. All right. Like I said, these are new slides. All right, so there are two cases. The first case is going to be greater than or equal to. So if you remember the last time we were working with inequalities, there were two options that you can put in here to make it work. So if we're looking at it being equal, you can put in 7, and the absolute value of 7 is equal to 7. Or you can also put in -7. So there is that negative case that you have to be, you have to remember that there is a negative case there. So the first case is things stay the same. So everything stays the same. And the second case is the negative case. So you flip the sign of the outside numbers. But in this case, with inequalities, anytime you reverse the sign, like in a way, it's kind of like multiplying both sides by a negative number or dividing both sides by a negative number. You flip the sign also. So in this case, the second case is not only -7, but switches from greater than or equal to less than or equal to. Now, let's go ahead and graph it. So x is greater than 7. So use a filled circle, the closed circle, so that way we can show that it is included in the solution. And we want numbers greater than 7, so put 7 over here, and x less than -7. So again, closed circle, less than 7 is over here. If you're not sure, you can always check it. So like, for instance, I know -9 should be less than -8. So if I plug it in here, the mouth is open towards -7 and away from -9. So it's true. And then interval notation. So as always, start from the left and work your way to the right. So coming from -infinity, we go to -7 and we just stop there. Union, because we have two sets, right? They're disjointed. And here I got 7, which is included onto infinity. And then we have the less than or equal to. So the less than or equal to option. And the only thing that's changing is which way this is facing. And that is a clue on whether they will face away from each other or whether they will face towards each other. But you don't really need to know like exactly which one is which. In most cases, if you just stick to your regular rules of solving absolute values and graphing, you should be fine. So again, first case stays the same, nothing changes. And now I am going to reverse the sign, so switch the sign and switch the sign of the outside number to a negative. So again, I'm switching kind of everything except what was in the absolute value sign. Now we can go ahead and graph it. So x is less than 4, so mark out 4. We need the or equal to, so close circle. And I'm going to point it this way. So again, it's x is less than 4. So again, it's like a game of hide and seek. If my clue is that it's hiding under a number less than 4, then that means I'd have to go this way to look for it. And then the same thing is true for this next one here. So x is greater than 4. We're going to go that way. So now I know where both of them are, so I can connect them. Make that a little bit better. Close enough. And then we have interval notation. So we only have a short interval from -4 to +4. And they are both included in their solutions. So we're going to use the square bracket to show that they are included when we put them into interval notation. And those are the two cases. And again, you don't really have to know the two cases as long as you stick to your basics on solving and graphing absolute value inequalities, then you should be fine. So what exactly does it mean though? So absolute value inequalities and compound inequalities are kind of the same thing. Absolute value in E. I should have left this on there before. Are compound inequalities. Gosh. I'll put also in there. So they are also the compound inequalities and absolute values have a lot of the same things. They are essentially the same thing, because anytime you have an absolute value, remember there's going to be two options. You're going to have what if the inside was negative and what if the inside was positive? And if you graph both of them, you're going to end up with two inequalities on your graph. So that's basically what it means. All right, so next thing is the steps. So how do we solve them? So if you remember solving absolute value inequalities, or just absolute value equations were the ones we covered, it's going to be the same steps. So isolate the absolute value expression. Make sure you get that thing by itself before you start working on it. Create two cases. So use the what we call KISS method, and that is keep it, switch, switch. So the first case, you're going to keep it the same, just remove the absolute value, and then the second one, you're going to switch the inequality, so the direction of the mouth opening, and you're also going to switch the sign that is on the outside number or numbers. Then you're going to solve both cases and then graph it and then write it in interval notation. So again, it's not anything that we haven't done before. We're just bringing two things that we already know together. All right, so let's go ahead and work on those methods. First thing we got to do, again, is make our two cases. So it's already isolated, so I don't have to worry about that. X plus 6 greater than 7. And now I need my second case, x plus 6. And again, switch the direction of the sign, the inequality, and then flip the sign of the number. So it's positive 7 to negative 7. From here, it's just basic algebra. So same thing as solving equations or solving inequalities. Same rules. And when I mean same rules, I actually do mean everything is pretty much the same as solving inequalities. So things like dividing both sides or multiplying both sides by a negative is still going to cause your inequality sign to shift or switch. But again, we're not going to flip it in this case because you don't need to flip it if you just minus something. All right, even if it's a negative or whatever, what adding and subtracting is not going to cause it to switch. Because I oftentimes get that too, where people just sort of get switch happy and start switching it on everything. All right, so there we go. We solved both sides. Not bad. So our solution is either greater than 1 or the solution is less than negative, or less than negative 13. All right, so then we graph each one. So x is greater than 1. Do you change the value of the 6 within the absolute value sign? No, we don't change it. You could, so if you were gonna, okay, so it's easier to change the numbers on the outside. Okay, so like in this case, if I change the outside number, I only change 7. But if I wanted to, could I? Yeah, I could. My cases would look something like this though. I'd have to switch two things while I keep it the same. And then my first case would be the same, like that. Actually, I'd have to change this one here. But changing it like this kind of gets confusing because you see how I have to change x and 6. So if I did that, I'd have to change both of them. And in this case here, I'd have a negative, and I'd have to remember to do the sign switch thing. So as far as I know, yeah, you can do it, but it's easier to switch the smaller thing first than it is to switch, a bigger group. It's kind of like if everyone's voting, it's best to just go with what would make everybody happy. Like if you have a family trip or something, and you're going to, everyone wants Chinese food, but then one person wants pizza. So, it's best to just go with what more people want instead. All right, so x is less than 13, so go over here. And x is greater than 1, so if I'm looking for numbers, it would be greater than 1. But again, this is just an easier way because I only have to change one, or in this case, 2 things, whereas over here I'd have to change 3, sometimes even more. And remember, these equations can get really big too, so it's easier to just keep it kind of simple and change fewer things. But anyway, there you go. Last thing is interval notation. So that would be negative, infinity. So coming from here, it's a long way, and it stops there at negative 13, which is not included. So we're going to use the parenthesis. Union, again, meaning that it has both of these solutions. It could be either from negative infinity to negative 13, or it could be from 1 to positive infinity. So it could be either one of those. And that's what the union symbol means. It means like also, in a way. If you take higher level mathematics, it's mainly used in Venn diagrams, but in this case here, it just means it's also included, basically, is all you have to know. So there you go, we're done with that one. Let's go ahead and go on to number 2. So I think most of these ones on this the first page where it's the first 4, they're really not that tough. You're just basically practicing your basics, and that is to break it into 2 cases. So 2v, I missed that restaurant. So first one stays the same, keep it. So that's the ki, and then the ss is to switch. So switch, switch. So again, just switch this sign and switch this to a negative. There you go. And I always got to double check these two because, I might forget to switch them. Plus 3, so let's go ahead and solve this side first. So add 3 to both sides. 2v, and 19 plus 3 is 22. Now I need a number that I can times by 2 to get 22, or just divide both sides by 2. V is less than 11. All right, so we got the first part. So V is less than 11. So let me go ahead and mark out 11. It doesn't look like they give a spot for 11, so we're probably gonna have to kind of make one between 10 and 12, because that's where 11 would be. And I'm gonna mark it with a little tiny mark here pointing this way. And again, try to avoid using shortcuts for this graphing, okay? Picking a point and testing it takes like 2 seconds, and it works way better. So if I pick 4, which is a number I know is definitely less than 11, plug it in for V. 4 is less than V. Okay, I'm sorry, 4 is less than 11. So that is true. 11 is the bigger number than 4, so the mouth is open towards that one. So it's true. We know we're pointing in the right direction. Plus 3 to both sides, 2v greater than, and now in this case it's going to be a negative. So that would be negative 16. All right, and then divide both sides by 2. So 2 gets canceled on this side. V is greater than negative 8. So again, our solution is either less than 11 or greater than negative 8. Now in this case, it looks like they're going to be pointing in the same direction because v being greater than negative 8, so there's negative 8 and we're going to the greater side. And if they're pointing towards the same direction, they include all the numbers between those two numbers. So this would actually not be an or, it would be an and. So it has to be between negative 8 and 11, not including either of those numbers. And again, it has to fulfill both of these requirements. Like if I pick 18, yeah, 18 is greater than negative 8, but it is not less than 11. So again, it's got to be between negative 8 and 11. So between negative 8 and 11. It's going to be parentheses because we are not including either of those in the solution. So if we pick negative 8, remember that hole means that you're just going to go right through that number. So you can't actually land on negative 8 or 11. Again, just a quick review, reminder about those little things. Okay, moving right along. Ooh, looks like we got one with a fraction in it. All right, so our absolute value is already isolated, so I don't need to do anything else really. I'm gonna just start making the extra cases. So k over 3, and again, keep it the same. And then the second one, I am going to flip the sign. I said flip the sign. So there you go. Now it's going to be opening the opposite direction and then change the integer to the opposite integer. So from 1 to negative 1. And then from here, we're just going to use our basic algebra to solve this one. So plus 5 plus 5. K over 3, and then 1 plus 5 would be 6. So what number can I divide by 3 in order to get 6? All right, so let's keep solving it. Since this k is being divided by 3, I'm going to do the opposite of divide by 3. Okay, let's see then. Now remember, that's divided by 3. We divided by 3 in order to get 6. So to cancel it, 3 divided by 3, that cancels here because 3 over 3 is just going to be 1, identity property. K is going to be greater than or equal to 18. Now remember, that would be 3 times 2 is 6. But that's good though. I'm glad you're participating. This is a good step forward. And thanks for your questions earlier also too. So there we go. We have our first part. K is greater than 18. But that's okay though. Sometimes these just work a little bit different than you think that they would be. For this one here, let me just come up with another really quick example. Like if I said, what number divided by 2 gives me 8? So think about it in a forward direction, okay? Think of a number divided by 2 to get 8. So, you know, it might say 4 because they're used to something like this, 2n equals 8. If they put 4 in here, 2 times 4 is 8. But we're working backwards, we're not timesing it, we're dividing it. So maybe you'll pick something, like if we pick 4 here, 4 divided by 2 is 2, but we're trying to get 8. So we need a bigger number, so let's try 10. 10 divided by 2 is 5. We're getting closer. We need 16, so that number would be 16 in order to get here. Yeah, so don't worry about that. That's actually a very common thing that usually happens, and that's why I tell students, whenever you're looking at a problem, you're not sure, think of it in terms of going forward, you know, because that's just my theory. I think people's brains work better going forward, you know, just like a car engine. A car engine will have it can go 70, 100 miles going forward, but if you try to make it go as backwards as fast as you can, it's only going to go like, I don't know, 30 miles tops, not 30 miles per hour tops backwards. Okay, so again, we gotta think of a number that we divide by 3 to get -4. So again, we're dividing a number by 3, and you could probably think, okay, so again, like 10 divided by 3 is like 3.3.
Mr. Nez,
Yeah.
how did you get -4?
Oh, my bad. I probably got carried away explaining what was going on. But yeah, you're right. It would be not that number. It wouldn't be negative. I think I was getting carried away with this here. But again, times both of them. So we got 3 canceling. K is less than 12. Now, before we mark which one it's going to be an and or an or, let me go ahead and mark out 12, and it's going to be less than. So we need numbers less than 12. So that would be this way. And in this case, since they're disjointed, they're not all together, we're going to put K is either greater than or equal to 18, or K is less than or equal to 12. So negative infinity to 12 and including 12. And the other part is from 18 including 18 to positive infinity. So basically we just can't pick anything in the middle of those two numbers. Okay. Let's go ahead and move to the next one. Okay. And again, create 2 cases. So keep it. So everything stays the same. And then in this case here, it would have to be negative 27. You know, something just occurred to me just now. I don't know why I'm doing this the long way. I'll show you what I mean probably if I remember for the next example. It's just taken me a little bit longer to do this. So let's go ahead and start by solving both sides. Just start with whichever one comes first. So -4, move 7 over to this side by minusing 7 to both sides, and you get 20. Now again, the rules are the same. If you're solving inequalities, you still got to remember that rule of divide by a negative. If you divide with a negative, that means you're going to have to flip the sign. So the mouth was facing towards the right. When I rewrite it, it's got to be opening towards the left now. Because when you multiply or divide, you're changing everything. Everything is changing. It's like it's kind of like if usually when I draw a picture of it, if you imagine like scales, right? One side has heavy weights on it, but if you replace those heavy weights with like balloons or something in negative, then the scale switches. You still have like say 5 pounds of weight or 5 big helium balloons, but it just causes everything to change. Maybe I need to like. I wish I could like draw a like a gosh like a computer, the way they have like those flash animations or something. You know, I think it would make a lot more sense to explain why this sign changes. But basically, again, you're just changing the meaning of everything in a way. All right, so n is greater than -5, so that means we're going to go this way. And in this case, I need a closed circle because it is included in the solution. And let's go ahead and do this one here. Okay, here's kind of what I was talking about earlier. Why don't I just, okay, that's not gonna work. It's gonna make me, oh, there we go. -4n greater than And they're both negative, so it's going to make a bigger negative. So that's going to be 34, because 7 plus 7 is 14. Carry the 10. And I run into the same problem. This is the same thing you got to watch out for. This is like, again, the only big difference between solving equations and solving inequalities is that whenever you divide by a negative, you are going to have to flip that sign. So I made it a habit to flip the sign first. As soon as I know it, as soon as I know what's going to happen, I flip that sign, because personally, I do forget things a lot. I mean, it's just kind of the way I am. So anyway, here I have 34 divided by 4, which I think we can break this into a decimal, and it would be about 8.5. And if you need to, you don't be afraid to do this, okay? Don't be afraid to do that. But now we have to put it at 8.5. So there's 8, 9. So 9 would be right here. So we got to put it right between 8 and 9. Close circle. And n is less than 8.5. So it's pointing this way. Now I'm going to test it with both of these. I'm going to test it with 0. So 0 is greater than -5. That's true. 0 is always greater than negative numbers. And if I plug 0 into n, 0 is less than 8.5. And that's true because 0 is less than positive numbers. So 0 is a good one to pick. It's just in the middle, you know, like when you need a decision made, sometimes you want to pick somebody who's neutral. So 0 works on both of them. So since they're both true, that means that they are both pointing in the right direction. And again, try not to use any shortcuts, because like let's say you forgot to flip the sign and now your 8.5 is going this way. Just an FYI, whenever you have these absolute value inequalities, they will pretty much never go the same direction. So they're never both going to go like right or left. Okay, they're always going to go in the opposite directions, either towards each other or away from each other. It's just the way they work. So if you ever get them where they go in the same direction, then you better check your work over again. So from -5 to 8.5, make that look more like a decimal, not a comma. And they are included, so we are going to use brackets to show that they are included, and we are done with that one. Okay. Before I do this one, I'm going to have to isolate that absolute value sign. So before I even start on this, I'm going to multiply both sides by 4. All right, so again, 4 divided by 4 is going to cancel it out. So it's not a fraction any longer. So q minus 1 greater than 8. Now it's still the absolute value. So I haven't created my 2 cases yet. Now that it's isolated, I can go ahead and create my 2 cases. So q less than 1 is greater than, 8. So there's my first case there, and this is what I was talking about. You know, we're not cavemen, we have technology. So I'm gonna just cut and paste it, and that way it saves me from having to write the whole thing over again. And I just gotta make sure to switch the sign. That was, I don't know if that saved any time or not, but it is what it is. So continue solving, add 1 to both sides. So we get rid of the 1, but we have to add 1 to this side now. So q is greater than 9, greater than or equal to. So since it's the or equal to, I'm going to fill it in. Then q is greater than 9. And now I got to solve this one. So add 1 to both sides. And q is less than -7. So go to -7, mark that out. Same thing, filled circle, closed circle. and it's less than -7. So if you're not sure, again, just check it. So if I plug in, say, -9, it should be true. So Q, if it's -9, which kind of already looks like 9, -9 is less than -7. That's true. If you have two negatives, remember, you want the one that's a lower negative number. And now time for interval notation from -infinity up to -7, including -7. And we're getting a little bit better at this, hopefully. Then we have here to 9, so including 9 on to infinity. All right, so that one wasn't too bad. All right. Moving on, same thing, we got to isolate that absolute value. First thing we got to do is isolate it. Once it's isolated, I mean, you could, if you remember what I said on that number 1, there is a way to do it without it, but you'd have to switch a whole bunch of signs. But it's just easiest. I mean, you're not going to get the wrong answer if you don't isolate it, but it's just the easiest thing to do if you just isolate it. All right, 8a plus 10 absolute value less than 25 minus 3 is 22. Now I can go ahead and create my two cases now that the absolute value is isolated. So 8a plus 10 less than 22. All right, those 2's are a little bit weird looking, so let me fix those. And again, I'm going to just see if I can cut and paste it so I can save myself a little bit of writing. Now I just got to make sure that this is negative and flip the sign. So let me just flip this here and make it negative. Now we have to start solving at -10 from both sides. 8a less than, in this case, it looks like we're going to get 12. And I'm going to have to divide both sides by 8. And it looks like we're going to get a non-whole number, a non-integer. And 12 divided by 8 is going to be 1.5. So if the top number is bigger than the bottom number, you're going to have a whole number part. But if I just type it into a calculator, 12 divided by 8, that is going to be 1.5. So a is less than 1.5. So 1.5 is going to be right here. And it means I'm going to have to go this way. And again, right now we don't know whether it's going to be towards each other or away from each other. At this point, it could be either one. All right, start solving this side here. So 8a greater than, and then they're both negative, so that's going to create a larger negative number. Divide both sides by 8. So that cancels this out. A is greater than. Now again, you don't need to flip the sign because we're not using the negative to divide. It's just the negative number is being divided. So not exactly the same thing. So I don't need to flip it. And -4. So it looks like we're going to have to move it over here. Open circle because there's nowhere equal to. And a is greater. And again, it has to fall between both of these. So it has to be less than 1.5 and greater than -4. Last thing, interval notation. Neither one is included. So we're going to use parentheses, and it just goes from -4 to 1.5. And there we go. All right. Now this one might be a little bit of a trick because we have, um, oh, did I mess this one up? For this one here, brackets, no, we don't need brackets on this one. Because there's no or equal to, if there wasn't or equal to, then it would be brackets. But if you're talking about this one, then yeah, we will use brackets for this one. So I mean, we could even put the brackets on there now because we know it's going to be an or equal. If it is an or equal to, then it's going to include those as part of their solutions. You're welcome. All right, so let's get rid of this 10 now. So 10, oh, but hold on a minute. We divided by a negative. So again, that's the thing you got to watch out for, all right? I mean, it'll sneak up on you like that. It'll come out of nowhere. Okay? Just like when you graduate, you're going to have some of your classmates come out of nowhere and ask you for money. Hey, remember we went to school together. Oh yeah, I remember you. Oh yeah, flip that sign. Like that. Okay. All right, so now we have the sign switched, so make sure that we take care of that. Now we have to break it into our two cases. So yeah, that sign switch can come from anywhere really. It's not, it can just sort of come out of the blue, just like that. And then now I have to switch these two signs again. So that's going to be less than -6. There you go. Now we have our two cases set up. Add 1 to both sides. 2r greater than 7. And it looks like we're going to end up with another decimal number because 7 divided by 2, if 2 goes in there, 2, 4, 6, it goes 2, 4, okay, 2, 4, 6. All right. Weird fact about me. I used to, from a job I used to have, I cut my pinky really deep, so I can't move my pinky on my left hand. So when I was typing, you might have noticed that I couldn't spell inequalities. So that's because I don't have feeling in the tip of my finger on this side. But since I made 2 mistakes, that's I don't know. You might have already noticed that. That was from like 10 years ago or so. The more you know about somebody. All right, r is less than, in this case it would be, so 5 goes in there 2 times, 1, 2. Right, that would be 4, but I still got 1/2 left over, so that would be 2.5. So r is less than -2.5. And r is less than that, so it means we're going to go this way. And here I have r is, oh, not negative. Sorry, I was looking at this one and that one. They kind of look the same. So sorry, I meant to put 3.5 here, but then I noticed that I put 2.5 because I was looking at that one also. So numbers kind of look the same. I just mixed them up here. So there you go. R is greater than 3.5 and less than -2.5. Okay, all right, there we go. and then going this way. All right, now let's go ahead and use our interval notation. So this one, in this case, they are not pointing towards each other, so it didn't make sense for me to write them. I knew there were going to be brackets in there, but oh, negative, okay, negative 2.5. And then from here, we got 3.5 included to infinity. So I knew there were going to be brackets in there, but we didn't know if it was going to be an and or an or statement. So in this case, it is an or statement because they are not, they're not joined, they're not together. So again, an or statement means that it's going to be either this side or that side, whereas an and statement means it has to be both of them. All right, I'm not sure if everyone got that, but like I said, hopefully you're following along. If you have your paper with you, you'll be able to write it. And it goes a little bit faster, I think, because now you don't have to write the answers, or sorry, you don't have to write the questions to what you're doing. Okay, with this one here, my first thought was to eliminate that 9, but looking at it a bit closer, it looks like I'm gonna have to get rid of this 5 first. So I'm gonna have to do a little bit of work before I can even break it into 2 cases. So I got rid of that 5, so adding 5 to both sides. And I still got to get that isolated, so that means I'm still going to have to divide both sides by 9. So that way I get 3 minus k, absolute value. And 72 divided by 9 is going to be 8. There you go. Now that it's isolated, I can go ahead and break it into my cases. So 3 minus k. And I'm going to try it this way here because I'm just going to cut and paste both cases and finish it up. So again, make sure this one's the same and this one is flipped, and then put a negative on that. So again, keep it, switch, switch. Minus 3 on this one here. So I'm trying to get that k by itself, but it's going to be a negative k. So this is kind of a hint of the things to come, because I am going to have to divide by negative 1. Now this is the way I think more modern teachers will do this. They could do it like this, or one other way I've seen is them doing the whole thing like that. So there's this one line, so that says everything is divided by negative 1. I don't know if that works any better, because the thing about doing it that way is that it tells you to flip the sign, right? Because it just helps to remind you that you have to flip the sign on everything. So k is negative, positive, less than is greater than now, and positive to negative. So everything switches. All right, k is less than negative 5. There you go, graph that out. And again, check it if you need to. Negative 8 is less than negative 5, that's true. And if you want to prove it false, you can pick 0. So 0 is less than negative 5, that is false. So the arrow is pointing away from it, so that means that it is indeed false. So it should not be pointing that direction. Now, let's go ahead and minus 3 from both sides here. And that would be negative 11. Negative k. And it looks like I'm going to have to divide by negative 1. Now, when I was in high school, I don't know if you guys have this same thing, but I remember teachers used to say, okay, if that happens, get rid of the negative by timesing everything by negative 1. And it's just like distributive property again. So negative k is positive k. This thing flips, and negative 11 is positive 11. Whichever one works for you. I think, again, more people are familiar with this one nowadays. oh, I need 11. 11 would be here. And k is greater than, so it's going to be opening this way. And in this case, they are disjointed, so we're going to have an or statement in there. Just need to work on our interval notation, so negative infinity to our smaller number, negative 5. And it is included, so bracket, union, and bracket again because we are including 11, on to infinity. Okay. We're making pretty good time. We did start a bit late. So I'm not really sure exactly how much time we have left, but oh well, I think we have enough time to go through all of these. With my morning class, I don't think I had enough time to go through all of them. So same thing, before we break it into our two cases, we have to isolate that absolute value sign first. So divide both, minus both sides. I'm looking at this 6 also, but we're gonna have to do that too. So that's gonna be 6 absolute value, negative 5n. And we got rid of the 7, so move that 7 over here, so that would be 30. Now, we got to get rid of that 6, because again, isolate it all the way. Now again, you don't really have to isolate it, but then you'd have to switch the signs, you know, like if you did this, you'd have to like switch the sign on that, switch the sign on this, flip that thing and switch the sign, so I'd have to do like 4 things, which is a bit of work and a lot to keep track of. Oopsie, almost forgot that other side here. Yep, there you go. So now we can break it into our two cases, negative 5n, and everything stays the same. And let's go ahead and cut and paste that because I'm going to need that exact same thing. So this is going to be negative, and this is going to have to switch to the other direction. Make that a little bit better. There you go. And there we go. Now we have our two cases ready to be solved. Doesn't look like there's much on this one, but again, be careful because if that variable is negative, that means that you're going to have to divide by a negative. So in this case here, I am going to have to flip the sign on both of these. So again, as soon as I know that I'm going to have to flip the sign, do that first, because again, I forget it from time to time. So if I forget it, then you're probably going to forget it even more. All right. Oh, that was kind of fast. I did both of them at the same time. That's usually the way I do it though. All right, so n is less than negative 1. And n is greater than positive 1. So with these ones, it's really just mainly the isolating that absolute value. Once you isolate it, it's not a big deal. So to negative 1, but not including 1. 1, not including 1. There you go. That one was a pretty fast one, but I think it's, again, just once you get the isolation part down, it's not so bad. All right. Now this one, next one here, I know is going to be a tricky one because it's one of those things that it doesn't seem like it would be that tough to spot, but whenever I see something like this where there's a group and there's two numbers, a lot of times students, they want to put those together, so negative 1, negative 4, and they get negative 5. But the thing is, they're not the same thing. This first number here is minusing 1. This is timesing by negative 4, so they're not the same thing. So you got to be careful with that and still continue to follow your order of operations. So again, you take care of the addition and subtraction first. So we do that. Let's take care of that by adding 1 to both sides. And in this case, it's negative, so it's going to be negative 20. There you go. So we got rid of that 1. Now let's get rid of this negative 4. So again, I got to divide both sides by negative 4. Cancel that out. X plus 9. And again, I'm just, okay, hold on a minute. We see, since I divided by negative, I almost missed that. Because I didn't say, oh, hold on a minute. No, we're dividing by a negative, so let's flip that sign. But I should have. I flipped it. And let's go ahead and create our 2 cases now. Fix that. It looks like a T. Don't want T. Get a plus sign there. And cut and paste. I don't know if this is saving any time or not, because I still have to erase it now. So that's going to be negative 5, and this is going to change. Okay, looks like I don't have to do much to these ones here. You know, it's just like 1 step to solving it. I said minus, that should be a minus 9. X is less than, and then put these 2 together, negative and negative, bigger negative, so it's going to be negative 14. And that one isn't too bad either. All right, so X is greater than negative 14, so mark out negative 14. And X is greater, so it's going to point that way. And again, I don't know which side this is going to be on, but it looks like it's also going to be negative 4, so mark that out with a closed circle. And X is greater than negative 4, so it's going to go this way. And let's go ahead and test it. Now, if I pick a number in the middle, they should both be false. So if I pick negative 10, so negative 10 is greater than negative 4, oops, that's wrong. And like I said, don't use any of those shortcuts because they don't always work. And again, checking it doesn't have to take that long. So if I pick something like this here, works out. And negative 2 is greater than negative 4, and negative 18, plug that in. Negative 14 is greater than negative 18. So there you go. And again, checking it doesn't have to take that long. And does include union, and also includes negative 4 on to infinity. All right. Interval notations, hopefully we're getting used to that, because like again, every time we have these things here, what we're actually doing is finding the domain. You know, domain is like possible values for X. And in this case here, we can pick any of these numbers. So that interval notation is something that's going to come back later. In fact, I think we're going to be using it throughout most of this course. So it's good to get used to that interval notation. Okay. Add 9, because I want to get that isolated. 3 absolute value 8x plus 5. And we got rid of that 9, so don't need to worry about that. Oh, and absolute value sign 2. Make them a little bit more bold. And then 24 plus 9 is 33. Divide both sides by 3. And now I should have my absolute value isolated. And don't forget, these are grouped too. You treat them kind of like parentheses. So if you wanted to solve something with a parenthesis, you could do the same thing and divide by the outside number. And that's kind of another way to get rid of that. And that's going to be 11. Now that it's isolated, I can go ahead and break it into my two cases. So again, first case stays the same. And second case is switched. So I don't know if this is faster than cut and pasting, but I don't know, I should time myself. It's probably about the same amount of time now that I think about it. All right, so get rid of this 5 by minusing on both sides, leaving us with 8x is greater than 11 minus 5 is 6. Divide both sides by 8. And let's see, cancel the 8, and x is greater than. All right, so in this case, my fraction has a smaller number on top, which means that it means I'm going to have a smaller number. So like I'm going to get 3/4, or you might say that that might be 0.75, like 3/4 is 75 cents. So to mark that 3/4 out, I'm going to go ahead and take the interval between 0 and 1, mark it into 4 equal spaces, and choose the third out of those 4. And x is greater than that, so that means I'm going to have to go this way. Minus 5 on both of these. Minus on both of these as well, so that'd be negative 16. Now this one does look like it is going to give us a whole number, which is good. Whole numbers are usually easier to work with. And 16 divided, okay, it's going to be negative, but 16 divided by 8 is 2. So it looks like I'm going to have to use negative 2. And negative 2 is right here, and x is less than negative 2, so it's going to go this way. And they are disjointed, so that means this is going to be an or. I think I've been a little bit bad. I think I've been missing some of those. But that's not really in the directions. The directions don't really tell us, you know, you have to indicate whether it's an and or an or. But I'm also just pointing it out too. So I don't know, when grading these, I probably won't be looking for that part. When grading these, I'm mainly going to be looking at your numbers here. You know, make sure you got the right numbers. And at least making sure your graphs are pointing in the right direction, right? So make sure if they should be pointing towards each other, away from each other. But again, they should not be pointing in the same direction. They usually don't do that. I mean, there are some very rare cases where they will go in the same direction. Oh, but again, that is really, really rare. Oh, it is too, okay. That's why I tell you, look at the graph. When you're making your interval notation, use the graph. It's a lot easier to just work your way left to right. Because I was looking at these ones here and I thought this one was the first one, but that's not always the case either. Okay. Last one. Looks like we're going to have to isolate the case again. For tomorrow, let me go ahead and say this while I think most people are here who are going to be here. Tomorrow we are going to have the test. So I'm not sure if some of you guys weren't here at the beginning of class, but I did mention that we're going to have a pre-test. So pre-test again, it's not graded by score. So it doesn't really matter how many you get right. You will get points just for completing it. There will be, I'm going to try to get some directions on how to, get to Schoology. So once you log into Schoology, I think it's one of the first items on the main menu. So on the main menu, there is going to be a big button that says pre-test, or a big item there that says pre-test on there. And it's about, I think it's like 40 questions. And I think most of them are multiple choice. But yeah. But that's it. So no lesson tomorrow. But I will be here tomorrow to check in. So if you want to check in for the attendance, just log on, say hi, and that's pretty much all you need to do. But again, that pre-test is going to be the main thing that you're going to have to work on tomorrow. We should have been working on it like first week of school, but with the whole computer system being what it was, it just didn't work out that way. Oh, I don't need these things here. Don't need these absolute value signs. All right, so there you go. Set that up, -9 on both of these. And just to make things go a little bit faster, I'm gonna go ahead and, yeah, and don't forget, you can also email check-in as well. So don't forget that either. I mean, that's always an option. So if for any reason you can't make it to the Zoom, you can always just send an email and tell me what's going on, or, just say I'm here even, All right, and now I divided by a negative here, so that's one thing we got to watch out for. So switch the sign, so that's going to be 1 or -9. Oopsie, made a big boo-boo here. I'm sitting here talking about all this different stuff. So that would be 4, or actually -4. And here n is less than 10. Okay, that's probably what you were just about to say. All right, but that's good that you're catching that, because like I said, I was just sitting here talking about the pretest. And depending on how that goes, I'm planning on having most like a quiz every 2 weeks, just like you would if you were here in person. You'd have a quiz like roughly every 2 weeks. Is kind of how I try to time it. And it'll be the same format, but again, the quizzes after this will be scored for points. So if you do badly on it, you're just gonna have to deal with that. But I'll probably work out something like, there'll be, how many more weeks do we have? We're on the 5th week, and we should have 4 more weeks. That would only mean we'd have 2 quizzes. Oh well. I'll work out something. I'll try to figure out a system that's fair and equal to both of these. In the meanwhile, that looks like it's it for the lesson today. So we'll go ahead and end the meeting here. I'll be around if you have any more questions, as always. If you need me to go back or do anything else like that, we can. All right, thanks for your questions.